All right, you guys, a couple people asked me to go over some of the stuff from this mole and molar mass Poggle. And so I am just going to go over the whole thing briefly, just to make sure that we feel really good about it going forward. So our first model is looking at otters, which are my favorite animal, but I'm not allowed to have a pet otter, so I just had to settle for these two dumb dogs, but they're pretty cute. Anyway, and we're also looking at an ammonia molecule, which is a really simple molecule, so it's nice to use in this situation. So the first question is like, how many tails are in a dozen otters? And we're really used to thinking about a dozen. We know that 1 dozen is 12 things. So if you have 12 otters, each otter has 1 tail, you have 12 tails. If you're looking at how many legs are in a dozen otters, hopefully all of our otters have 4 legs. And so we can just do 4 legs times 12 otters, which gives us 48 legs. The molecule for ammonia is just the same. So if we're looking at nitrogen, there's only 1 nitrogen in an ammonia, so we can say a dozen ammonia would have 12 nitrogen. If we want to think about the hydrogens in ammonia, there are 3 hydrogens in each ammonia. And so for that reason, we can do 3 hydrogens times a dozen, so 12 molecules, gives us 36 hydrogens. Then it's asking us how many tails. Oh dear, what did I just do? That was weird. Okay, I'm not sure what happened there, but anyway, how many tails are found in 1 mole of otters? And the answer to that is Avogadro's number, right? Each otter has 1 tail. If you have a mole of otters, you have 6.022 times 10 to the 23rd otters, which means you have 6.022 times 10 to the 23rd tails, which is a lot of otters. If we want to think about how many legs are on an otter, there's 4 legs on each otter, and then we have a mole of otters. So we can do 4 legs multiplied by Avogadro's number and find out that a mole of otters would have 2.41 times 10 to the 24th legs. Number 7 is going back to the ammonia molecule and saying how many nitrogen atoms would we have in a mole. And since a mole, oh gosh, excuse me you guys, as a yawn. Since a mole is 6.022 times 10 to the 23rd ammonia molecules, and each ammonia has 1 nitrogen, then we would have Avogadro's number of nitrogen. Then, once we're looking at our hydrogens, we know that each molecule has 3 hydrogens. So if we have a mole of molecules, we can do Avogadro's number multiplied by the 3 hydrogens and get 1.18 times 10 to the 24 hydrogens in a mole of ammonia. So for number 9, we can use the periodic table to calculate the average mass in atomic mass units of 1 ammonia molecule to 2 decimal places. And if we scroll back up to the top, it tells us a little bit about the AMU. So atomic mass unit is basically 1 proton is 1 atomic mass unit, a neutron weighs about 1 atomic mass unit, and then electrons are super teeny tiny, so we pretty much ignore them most of the time. And it shows us right here, oh, that's really awkward. It shows us that 1 atomic mass unit is equal to 1.66 times 10 to the negative 24 grams. So there's this relationship between the mass of something in atomic mass units and the mass in grams. And, you know, what you can see from that times 10 to the negative 24 is that protons are super, super tiny, which we already knew. So that checks out. Anyway, back to number 9. So we're looking at the periodic table And we want to know the average mass of one ammonia molecule. And so we can take that there's one nitrogen, so that's what this one means, and then there's 14.01 atomic mass units is the mass of a nitrogen. There's 3 hydrogens, that's where our little 3 is coming from, and then each hydrogen is 1.01 atomic mass units. So that gives us 17.04 atomic mass units is the average mass of ammonia. Based on this calculation and from number 9, we can take the mass in grams of one ammonia molecule to 2 decimal places. And so to do this, we use factor labels. So we start with 1 mole of ammonia. We know that 1 mole of ammonia is equal to Avogadro's number worth of ammonia, and 1 molecule of ammonia is 17.04 atomic mass units. Okay, that's where I pulled that from number 9. Then down here, I have that 1 atomic mass unit is equal to 1.66 times 10 to the negative 24 grams, right? And so this conversion factor right here on the end, this guy just came from the top of this sheet. It was a provided conversion factor. When I math this all out, so I multiply everything together, I end up with 17.03 grams of ammonia. And because we were looking at 1 mole, that's essentially, well, it's not essentially, it literally is the molar mass. 17.03 grams per mole is the molar mass of NH3. And this is really handy because it allows for us to calculate molar mass by simply adding up the number of each element and its mass from the periodic table. Hopefully that clarifies some things for y'all. If not, keep adding your questions to the comments and I will try again. I hope you guys are staying safe and sane. Remember to at least venture out into the sunshine a little bit. And if you have a pet, you're allowed to walk your pet. That's an essential activity. So I really encourage y'all to get outside when the weather is nice because being stuck at home can be really hard. Anyway, go walk a dog if you can. Get some sunshine. Love you guys. Bye.